Welcome back. Here is our work with our practice problems or with our homework problems. As we can see here with our practice problems below, we see something very similar to our classwork, where we're going to work on some rotations around the points that are related to the figure that's given. The first one, we're going to see a rotation in segment CD, 180 degrees around point D. Now, before we get going with that homework, I want to make a suggestion that when you're going through your homework, have your old lesson summary sitting there with you. Remember, we just went through this at the end of the lesson. Have this out with you, review it just before you do your homework, and then keep it here with you so you can see it's still with me. Have it there with you and make sure that you reference it as you go. This will help you to develop memory of the concepts that we're working with. So we see this, a rotation around point D, 180 degrees. Well, that rotation around point D, let's go ahead and take our figure. And let's think about this. You're like, well, man, Mr. Quilter, this isn't on graph paper. I don't see a grid like we had in our classwork. This is really confusing, and it's hard for me to recognize that. So, take a look at your homework and look at that homework, and let's figure out what would happen if we took the grid away. Well, if we took the grid away, when we had that little segment of 3 points, we saw that under a rotation of 180 degrees, we saw a straight line. So maybe what we need to do first is give ourselves our own little pattern, and we're going to say, let's go ahead and make this into a longer straight line, and that will give us a guide to know when to stop for a 180 degree rotation. So here we go. Let's take this segment C to D. Let's go ahead and put this on here. We're going to leave M out this time. We just want to work on this. A 180 degree rotation around point D. Now, how do I know when to stop? Well, because I understand that a 180 degree rotation is a straight angle, I'm going to stop when I get to that straight line. And what that does, it gives me a little template to follow. And then I can come up here, hover over my point so I know where to put it. There's my point right there. And then that point out here becomes C prime. In here where we rotate around D, we can call that one D prime. And then we see that our rule that we talked about right here that says our second rule, the image of the segment overlaps with the segment and lies in the same line or is coincident with the other line if the center of rotation is a point on the segment. And since D is a point on the segment, this is what we're talking about, an overlap. It just continues that pattern. It lies on the same line. Let's go ahead and do a rotation around point E. Point E is right here. Oh man, 180 degrees. How do I know where 180 degrees is with this one? Well, again, we go back to our work and we say the point is off. The center is not a part of the segment. So we should see an image of the segment does not overlap with the segment, but my consequence is parallel lines or parallel segments. So when I go to do my rotation of 180 degrees, I need to stop when I see a parallel relationship here. Well, how do I know if it's exactly parallel? Since there's no grid lines, I'm going to give you a little bit of a break and say, give me your best estimate. That is clearly not parallel. Neither is this. But as I come around here, this looks really close to parallel. You do have some options here. I mean, you can go ahead and take a ruler and measure to get the measurement from here to here and see how far is it. And that looks like 3.3 7/10 centimeters. And then I come down here and I'm like, oh, that's not quite 3 7/10. But if I can bring this back just a little bit, that's more like 3 7/10. And just, make sure that it's truly parallel. Otherwise, something that's super close, I'm okay with that. So one point's going to be right there above the O. The other point is going to be right here. Hover across. Don't move your pencil. Put a point there. The other point was right here. And just give me something that looks very, very close to where it should have been. And then get that picture. But be careful that when you label your image, that you're labeling it appropriately. That 180 degree rotation, if you forgot to label it and you're trying to think, man, how do I do this again? Well, remember back to what I talked about with corresponding points. and how those corresponding points lie in a straight line through the center of rotation to the related point, or what we call a collinear relationship. And so since I forgot to do that, the two that are a relationship from C to E, that straight line comes all the way back across to this other point. This point up here is C prime, which means that this other point right here is D prime. Now, if I go ahead and do a rotation around point M, that one's kind of nice. Point M, as we remember, we can put that in there. M is the midpoint or the center of segment CD. So let's come over here and we're going to mark center M, and we're going to rotate 180 degrees. Recall that our rotation of 90 degrees makes perpendicular. 180 degrees would overlap back onto itself. Take a minute. What's the name of that word for overlap or becoming part of the same line? Overlap, overlap, overlap. There it is. Bullet point 2, coincide. So we see that these lines coincide, only this becomes D prime and this becomes C prime because the two figures switch their places 180 degrees away. So D prime and C prime. There you go. We see that rotation. What about when we rotate a triangle? Well, remember, as we talked about this in our lesson, the very first thing that we did, here's an isosceles triangle, and we're going to draw these three triangles. Triangle ABC, draw three rotations of triangle ABC together. Well, rotate triangle ABC 90 degrees clockwise around A, rotate triangle ABC 180 degrees around A, rotate 270 degrees around A. That sounds super familiar. So without being redundant, I'm just going to show you this. This was the very first thing that we did. Recall this from the lesson from the very beginning, and then we can actually do the exact same thing with this figure right here. Finally, problem number 3, excuse me, not finally, problem number 3 talks about each graph shows two polygons. This graph is the one that we're talking about right here on my next page. Polygon A, B, C, D, and A prime, B prime, C prime, D prime in each case. Describe a sequence of transformation that takes the original to the copy. So you're going to describe a transformation, rigid transformation, or a sequence of transformations that takes this figure to this figure. What I want to recognize with these figures and what I probably see, what I see first off, is I actually kind of see two halves to a heart. So let's mend this broken heart and fix this one to this one. That's AB, AD, DC, BC. And I'm just going to simply translate from point D to D prime. And there I fixed the heart, but it's not done yet. So there's one more transformation that needs to happen. What is it? Please remember the video from yesterday when we talked about using precise language, that every rotation, translation, and reflection, you have to name the figure, you have to name the move, and you have to name the things that go with that move. Don't forget that they all have their pieces. I'll get you started with the first one by saying here, translate. We're going to call this quadrilateral. Quadrilateral A, B, C, D from D to D prime. And it's up to you to create the next bullet point. We're going to go number 1 and then move number 2. It's up to you to get move number 2. Do I have to follow this order? Do you have to translate first? Certainly you do not. There are other ways to do this, but please make sure they're accurate and you're using great language as you see right here. The next one, we have quadrilateral ABCD down here. And we need to figure out how to get this figure to its prime figure, or its image. Again, we have a lot of options. I could start by translating over here to figure C. I could start by figuring out the degree of rotations. You know, if I bring this over to the top of this one, or if I look at it to see how do I make this the same. Well, this is comparing C to D. I rotated it 90 degrees, and that rotation of 90 degrees fits. So that helps me to understand that I have a rotation of 90 degrees clockwise, or if I go the other direction, a rotation of 270 degrees counterclockwise. They are opposites, and then I would need to, of course, if I do the rotation, either I rotate first and then translate it, or I translate first and then rotate it. Either way is fine, but we need to have the best language possible to do this. Finally, we have Lynn that has an example. She says, can we take polygon A to polygon B with only reflections? She says we can. Do you agree with her? Talk about it, experiment with it. Don't just assume that you can reflect it straight across, because right now there are no lines of reflection. Experiment with it and play with it. I hope that this helps you with your homework. Do a great job with it. Please, again, we are really, really focusing on using the best language possible. Make sure that we use that language. If you need to use drawings, please use drawings to help us out and include that in there. The visual representation helps to make your descriptions a lot clearer. Good luck today with this. Again, never give up. You're doing great. Take care.